right, so AI. Everyone's talking about it, okay? But have you ever wondered, like, what it actually takes to build these crazy, powerful AI models we keep hearing about?
Yeah, it's really incredible, the sheer scale of it all.
Right, like, we're not just talking software updates here. This is, like, next-level stuff.
Absolutely. We're talking about building the infrastructure to train models so big they make, everything we've seen before look tiny.
Okay, so give me an example. How big are we talking?
Well, some of the leading AI models right now, they're already being trained on clusters of, get this, 100,000 GPUs.
100,000. Seriously.
Yeah. And the projections for next year, over 300,000, it's
That,
mind-boggling.
that's more computing power than, like, most countries.
It's true. It's more than most countries have.
So, I mean, how is that even possible? You can't just keep cramming GPUs into a single building, right?
That's the thing. You hit a wall, a very real, very physical wall.
Okay, I'm intrigued. Tell me more about this wall.
Well, think about it. Power grids, cooling systems, even just the building itself. There are limits to how much any one location can handle.
So what do? You need more space, but you can't just build one massive supercomputer.
You got it. And that's where multi-data center training comes in.
Multi-data center training.
Yeah, like instead of one giant brain, imagine a network of brains all linked together, learning in unison.
That sounds like something straight out of a sci-fi movie.
It kind of is. And according to this report from Semi-Analysis, that's exactly what companies like OpenAI and Google are going for.
OpenAI trying to beat Google, huh? Sounds like a David and Goliath situation.
It does, doesn't it? But you got to remember, Google, they've got those massive data centers, years of experience. Remember those pictures of their facilities? The gleaming white hallways, servers for days, perfectly temperature controlled.
Oh yeah, those are impressive.
It's intimidating. But even giants can stumble. And Google's system, well, it might not be cut out for this whole distributed AI training thing.
You mean they're not set up for this multi-data center approach?
Yeah, see, Google's whole empire, it's built on synchronous training. Imagine, like, a perfectly synchronized swimming team. Every GPU moving in lockstep, sharing info constantly.
Okay, I'm kind of getting it. But what happens if one of those swimmers is off?
That's just it. Even the tiniest delay can throw everything off. It's efficient, sure, if everyone's on the same beat, but...
But in the real world, things don't always go perfectly to plan.
Exactly. And that's why OpenAI and Microsoft, they're going all in on something different. Asynchronous training.
Asynchronous training. So, like, the opposite of synchronized swimming.
Kind of. Think of it more like a bunch of really smart people, each working on a piece of a puzzle, but independently.
So instead of constant communication, they just share their findings every now and then.
You got it. And that's the beauty. It's way more fault tolerant. If one person, or in this case, one GPU, hits a snag...
The whole thing doesn't fall apart.
Exactly. The others can keep going.
Okay, so OpenAI, they're going for this asynchronous multi-data center approach. What's the catch? It can't be that easy, right?
You're right, it's not easy. Not even close. In some ways, it's like trading one set of problems for a whole other beast.
A beast. Okay, now you've got to elaborate. What kind of beast are we talking about?
Well, imagine this. You've got thousands of these processes happening every second, information flying back and forth between data centers. And not just across town, we're talking continents apart.
Okay, yeah, now I see what you mean. Keeping all that straight, that's got to be a nightmare.
It's a whole new level of complexity. And it's not just about building faster networks, it's about rethinking the entire system. The software, the algorithms, the whole shebang.
So how do they even start to tackle a problem this big? Where do you even begin?
Well, they're coming up with some pretty ingenious solutions. One key idea is this concept of sparse updates. So remember we were talking about those parameter servers, those central hubs where groups of GPUs share their progress?
Yeah, like the handoff points in a relay race.
Right, exactly. Now imagine you've got thousands of these handoffs happening every second, information flying back and forth between data centers, sometimes, on opposite sides of the world.
Okay, yeah, things are getting complicated.
They are. And with these sparse updates, instead of each, let's call them runners, transmitting every single detail at each handoff, they only share the most important changes.
Oh, so they're cutting out the noise, focusing on just the essential stuff.
Exactly. It's all about efficiency at this scale.
Makes sense. But how do they decide what's essential? That seems pretty subjective.
That's where it gets really interesting. They're using these sophisticated algorithms to identify which updates have the biggest impact on the model's accuracy overall. It's like having, I don't know, a team of super editors who can go through a mountain of data and pick out the most important sentences.
Wow, that's That's pretty amazing. But even then, we're still talking about a massive amount of information being thrown around, right? I mean, these
Well,
models are trained on, what, trillions of words
Yep,
in code.
you're not wrong. And that's where the limitations of our good old-fashioned networks, they become really obvious. You see, even with fiber optic cables, distance still matters. Sending data from, say, New York to Sydney, it takes time.
And when we're talking about milliseconds making a difference.
Exactly. Those delays, they add up fast. And it's not just about speed, it's also about bandwidth. Imagine a single-lane highway trying to handle rush hour traffic in a megacity.
Okay, yeah, not a pretty picture. So they need faster connections, more bandwidth, and on top of all that, they still need to make sure the data itself is clean. Didn't we talk about data corruption earlier?
We did, and that's still a huge concern.
So what's the solution?
Well, there's no easy answer, but companies like NVIDIA, Mellanox, Arista, they're all working on building specialized hardware and software to address these challenges. It's a whole new world of high-performance computing.
It's incredible, really, this whole race to build better AI. It's pushing the boundaries of so many other fields.
It's a ripple effect, and the investments are enormous. We're not talking millions here, not even just billions. We're talking potentially trillions of dollars pouring into this over the next decade.
So who's winning? Is it Google, with all their resources and experience? Or does OpenAI have a real shot at taking the lead?
Ah, the billion-dollar question. You see, Google, they've got this classic innovator's dilemma. Their infrastructure, as impressive as it was built for a different time. Switching to this new asynchronous multi-data center approach, it's not going to be easy.
Like trying to turn a cruise ship around on a dime.
Exactly. And that's where OpenAI might have an advantage, starting with a clean slate. They can build for this new world from the ground up. And with Microsoft in their corner, well, they've got access to a lot of resources and expertise.
So it's a real underdog story then. But even with Microsoft on their side, Google's still, Google.
Right. Like they've got the track record, the resources, and let's not forget the data. Don't underestimate the data. They've been at this for decades, indexing the internet. That's a gold mine when it comes to training these AI models.
True, true. So how does OpenAI even begin to compete with that? If data is king, isn't it game over already?
Well, not so fast. It's not just about how much data you have, it's about what you do with it. The quality, the variety. OpenAI is taking a different approach, focusing on really high quality data sets and using things like reinforcement learning.
Reinforcement learning. Refresh my memory. What's that again?
So instead of just feeding the AI tons of data, you let it learn through interaction. It's like it tries something, gets feedback, and adjusts its approach based on that. More like how humans learn, actually.
Interesting. So it's less about force-feeding information and more about letting the AI learn by doing.
Exactly. And OpenAI's got a pretty impressive team working on this stuff. They're not afraid to experiment, to push the boundaries a little.
And they're not just doing it alone, right? There's the whole open source angle too.
Right. They've been strategic about it, of course, but they have released a lot of tools and data that have had a big impact on the field.
It's funny, isn't it? OpenAI trying to, open up AI development. And then you have Google, this massive company, with all their talk about don't be evil.
Yeah.
But at the end of the day, they're still driven by profit, right?
That's the reality of it, yeah.
Whereas OpenAI, at least in theory, they're all about making sure this technology benefits everyone.
It's a different philosophy for sure. And if they pull it off, it could really change the game. Imagine a future where the most powerful AI isn't controlled by a few giant corporations, but is accessible to, researchers, developers, artists, even entrepreneurs all over the world.
It's exciting, but a little scary too, right? I mean, we've all seen those movies where the AI becomes self-aware and decides it doesn't need us anymore.
It's a valid concern, and it's something OpenAI takes seriously. They've been pretty vocal about ethical AI development, building in safeguards, that kind of thing.
Well, that's good to hear.
Yeah.
But even if we avoid the whole robot uprising scenario, there are still so many questions, right? Like, what happens to jobs when AI can automate more and more tasks? How do we make sure it's used for good?
Big questions, and not easy answers. But one thing's for sure, AI is here to stay, it's already changing the world, and it's only going to accelerate from here.
So what's the takeaway for our listeners today? What should they be thinking about?
I'd say the most important thing is to stay informed. Stay curious. This isn't just a technology issue, it's a societal one. We all have a role to play in shaping the future of AI.
I like that. Well said. So, to leave everyone with something to think about, imagine a world where anyone, anywhere, can access the power of AI. To solve problems, to create, to build, what would you do with that power?
Now that's a question.
It is. And on that note, this has been our deep dive into the world of multi-data center AI training. Thanks for listening, everyone, and we'll catch you next time.